video, we're going to learn how that there's two different forms of a linear relation. There's two different forms of the equation of the linear relation. You don't really need to know uh, these two equations in depth till Math 10 Common, but you're definitely introduced to the two forms in grade 9. And another thing is we're going to learn how to graph horizontal and vertical lines in the second video of this lesson. So let's go on. So there are two different ways that we can write a linear relation. The one that we've been dealing with so far is actually called slope-intercept form. And if you notice that all of the equations that we have been given has had y by itself. Okay, so here's some examples. So we have graphed y is equal to 2x plus 1. We have graphed y is equal to, I don't know, negative 5x plus, we can even put a fraction in there. Okay, so let me just talk to you about a few different things. X is your independent variable. Remember we're in lesson, I think it was in lesson 2, we talked about independent variables. X is actually your independent variable. Y is your dependent one. These two, this M and this B, and I know that we have to really think abstractly here. The M and the B are what are called parameters. And they are numbers, like notice, the M here is 2, the B here is 1. The M here is negative 5, the B here is 1/2. When we change the parameters, we're going to get a different line. And you are going to be investigating those things, or that in grade 10 common or in Math 10 common in high school. So right now you just need to know that there's two different forms of the line, and you will only have to be able to graph the equation. Sorry, we have to graph the linear relation from either equation. So the other standard form, or the other form, is standard, and you are going to have it in this form. Ax plus by is equal to c. Now again, we still have an x, we still have a y. Okay, so those are still your independent and dependent variables. They can be t and d, they can be anything, but you do need to have some sort of variable in there. Now, in standard form, capital letter A, capital letter B, and capital letter C are your parameters. Once we change those, there has to be numbers in there. Once we put numbers in there, we're going to get a linear relation. We change those parameters, we're going to get a different line. Okay? So we're just going to learn how to graph. We've done many of the graphing in slope-intercept form. In this one, we've done those in lesson 1 and lesson 2. Now we're going to have to practice doing it in standard form. So notice here that I have, here my big A is 2. If I put, remember my invisible number is 1. So see how I changed my A is 2, my B is 1, my C is 6. Like going back to ax plus by plus c. I now have a line. Here's my independent variable, my x, and my dependent is still my y. Okay? I'm just going to erase it so we don't get confused. Now, I'm going to tell you which values to use. So I'm going to tell you to make a table using x is equal to negative 3, x is 0, and y is equal to 3. Okay? So I'm going to put those in. So now what I need to do is find the corresponding value of y when x is equal to negative 3 for this linear relation. So yes, we have to do a little bit of algebra. So I'm just going to extend my page here. Whoops, I forgot my 2x plus y is equal to 6. Okay? So now I say that x is equal to negative 3. So where I see an x, I'm saying it's equal to negative 3. So I take the x out and I put negative 3 in it. I simplify. because that's multiplication there, so I simplify it. And now this is going back to grade 7. This is just now a simple equation, okay? In order to solve for y, I have to get rid of a -6 because I want y by itself. So in order to get y by itself, I have to zero out the -6. When I zero out a -6, I do that by putting a +6. Now remember, in grade 7, if I add 6 to one side, I must add 6 to the other. Now this zeroes out, and I get 12 here. So when x is equal to -3, my y has to equal to 12, otherwise my equation doesn't make sense. And we do it the same thing now for when x is equal to 0. There is no shortcut to this. Don't try create your own math like some of my students do. Okay, so I'm not going to rewrite the equation. I know I have it right there. Now wherever I see an x, I'm going to replace it with 0. So that's what I just did here. I simplify first, so I have 0 plus y is equal to 6. And this is already zeroed out, so I know y is equal to 6. Okay, now from here we can go and do the same thing for 3, or we can follow our pattern because this is going up by 3's. This one is going down by 6, so I can just use my patterns. If this is a constant on this side, this must be a constant. That's the whole definition to a linear relation. But let's just double check. I'll show you that it actually works. So let's take the x out and put the 3 in. So I get 2 times 3. I simplify first. 2 times 3 is 6. And then I zero out. +6, -6. That's how you zero it out. So this zeros, and look what happens. That 0 too. So I can see now that it works. Now that I have my data values, I go and I graph my linear relation. Since I have negatives, I'm going to put my grid or my axes in the middle of my grid. Remember to label your axes. So I have an x and a y. And I'm just going to label what I have. -3, +3, here's my 0. And now I have 12 and 6. So I have, I'm just going to count this 1, 2, 3, 4, 5, 6. So I can go up every 2. So this, if this is 2, this is 4. This is 6, this is 8. This is 10, this is 12. So I have all my data on my grid. So -3, +12. 0, 6, 3, 0. And I can see that it is on a linear line, or a linear, it's on a line, darn it. Let me just, there, that's what I wanted. Oh, look at that, it's perfect. Okay, now let's talk about the reason why I connected those dots. Since there is no context to this equation, it is just a linear equation, or linear equation, we connect that. We assume that it is continuous. If we're not talking about people, we're not talking about bodies or animals or bacteria or anything like that. So whenever there is no context to the problem, it is a continuous graph. We do connect the dots. Okay, good. So let's try this one. This one's a little bit harder. Again, I give you the example. Notice that this is in standard form. Here's my A, here's my B, here's my C. So A, B, and C are taken care of by numbers. I have my independent variable, and here's my dependent. Okay, I'm going to erase that. Just showing you that it's in standard. I'm giving you the values. And the reason why I'm giving you these values is because I know you're going to get nice numbers. Okay, I know you're going to get a nice number and not a fraction or a decimal. In grade 10, you're going to have to be able to graph anything. Like you're going to get decimals and fractions and stuff as your y's. So I'm just giving you ones that I know are going to work. So we have 3x plus 2y. Like I said, there is no easy way to do this. So we do this nicely, carefully, so we don't make any mistakes. Now I'm telling you that my first value of x is negative 2. So I take out my negative 2, or sorry, take out my x, I put in my negative 2. I simplify first, so that gives you negative 6 plus 2y is equal to 6. Now I have to solve this equation. We have done these in grade 7, and you should have done them in grade 8. So the very first thing you do is zero out. So if you have a negative 6, we zero it out by a positive 6. Okay, that zeroes out, and I get 2y is equal to 12. Now this means 2 times some number is 12. So to get rid of a 2 times, we must divide. And we get y is equal to 6. Those two cancel, and I get y is equal to 6. So when x is equal to negative 2, in order for this equation to work, y has to equal to 6. Okay? We do the exact same thing when x is equal to 0. So let's just say 3x plus 2y is equal to 6. Now I'm saying x is equal to 0. So I put my 0 in. And again, I simplify. I divide by 2. I already have my 0, so I'm going to divide both sides by 2. And I get y is equal to 3. Now again, check for patterns. We know that linear relations have constant patterns for each of their variables. So this is going up by 2. It's constant. So if this side's constant, this side must be constant. So I really don't have to, look at that. I don't have to do the third one. As soon as I see all of this, I know I can just subtract 3. We can see if it works, but I'm going to continue on, and I'm just going to do my graph. Okay, I'm just going to bring this up. I'm just going to put a negative 2, that's 0, positive 2. I got all my x values. Here I have 6 to 0, so let's go 3, 6. Okay, as long as it's scaled properly. So I have negative 2, negative 6. Sorry, negative 2, positive 6, 0, 3, and then 2, 0. I draw my line. I'm just going to make sure it's there. I connect the graphs because there is no context to this question. It's just a linear equation. I assume all of those are continuous graphs. Okay, so what we've just done is graphed oblique lines. In the next video, we are going to learn about horizontal and vertical lines.